2.08 times 10 to the negative 33, which means this is not all that soluble, is it?
No.
Okay. Let's go over some vocab, most of which you know. Now you need to just put it into context with the KSP. A saturated solution is a solution that contains undissolved solute in contact with the solvent. That means in a saturated solution, what you would have is, in this case, you would have some calcium phosphate on the bottom of the beaker. Solubility, like the solubility curves that you have read and promised me that you would never guess supersaturated, is generally on the y-axis, has the grams of solute per liter of solution. All right, you remember that under the curve was unsaturated, on the curve was saturated, and you had to do something extraordinary to make it supersaturated. Okay, you can connect solubility in grams of solute per liter solution to the molar solubility, and quite frequently it's in molar solubility, which is the moles of solute dissolved per liters of solution. So you could do a simple calculation to get from here to here. Likewise, if you are talking about a compound, like calcium phosphate, you can talk about the molar concentration of its ions. So for every mole of calcium phosphate, I would have 3 moles of calcium ion. That's again a different, just another calculation. And you can also talk about KSP based on its KSP expression. Good? All right. The KSP for silver chromate is 1.12 times 10 to the negative 12. What is the molar solubility of silver chromate? Well, I have my KSP value. KSP is equal to the silver ions and the chromate ion.
The little thing you put in there.
It was a mistake, so I'm not going to do anything with it. I started with a plus sign in front because I lost my mind. What's going on is the silver chromate initially is a solid. Once it reaches equilibrium, you have 2 ions of silver and 1 chromate ion. So initially you have none of this. We don't really even worry about the concentration of the solid because it's not going to be a player in our rice table. But for every one of these that breaks down, 2 of these will be formed and 1 chromate. So at equilibrium, you'll have 2x of the silver and 1x of the chromate. And when you look at that, all you're doing is making sure that you have, you're counting your atoms. So if I plug these values into my KSP expression becomes, for my silver, 2x raised to the 2nd power times x is equal to the KSP, which is 1.12 times 10 to the negative 12. Okay. This is 4x times x is equal to 4x cubed. So 4x cubed is equal to 1.12 times 10 to the negative 12. Thank you. I am dropping digits all over the place today. Better be careful. So divide this by 4, and then on your calculator, under the math section, you have a cube root key.
6.54 times 10 to the negative 5.
Yep. I'm going to call that 6.5 times 10 to the negative 5th, and that's moles per liter. So that's the molar solubility of the silver chromate. What's the solubility? And you'll notice they just said solubility. If they say just solubility, you are assuming they mean grams of this. I think that's just a little calculation. The number of grams equal to 6.5 times 10 to the 5th moles per liter of the silver chromate. 1 mole of silver chromate has a molar mass of 332 grams. So my solubility will be 2.2 times 10 to the negative second grams per liter. And while my molar solubility was 6.5 times 10 to the negative fifth moles per liter. All right, so the tricky part is making sure you're answering the question they are asking based on these relationships. And off we go to the next part. And this is you doing this by yourself. You can stop it for the calculation portion.